Okay, this is going to be a series of videos, so the one you're watching is only one of a series, and I do encourage you to watch the rest of them. Also, I encourage you to watch the full-length webumentary titled Global Warming, Myth or Reality, A Skeptic's View. It goes through the entire science behind global warming, but with this series, we're going to pick and choose some interesting pieces, and we're going to ask the viewer, does global warming pass the stink test? We're going to take a look at the science, and I want you to ask yourself, does that even make sense? Most importantly, ask yourself, if a big oil company produced a report like that, wouldn't the environmentalists be going ape nuts? Because what we're going to do is we're going to take a hard look at the science, and then once again, just ask yourself, does this pass the stink test? Okay, today we're going to take a look at how you lie with numbers. And the advantage that the global warming theorists have is that they understand that most people have never taken upper level statistics. They've never taken econometrics. They've never taken multivariable linear regressions. They've never taken forecasting and modeling. So when they make these claims, they know that the public doesn't know to look for certain things to determine whether it's a valid model or not. Well, anytime you create a model that they're doing here, which is basically what's called a time series model, and they're saying that one factor causes the other factor to change. They say CO2 causes temperature to increase. Well, the first thing you would look for was, A, if that's in fact true, you would have to see a variation in carbon dioxide first and then temperature change. You have to show cause and effect, but the critical part is that one must lead the other. CO2 changes first, and then temperature changes. The way you do these kind of studies, you'd collect data on those two variables. In that situation, the temperature would be the dependent variable, and CO2 would be the independent variable, meaning it changes by itself, and when it changes, it then causes a change in the dependent variable. That's where they come up with those terms. Well, what you do is you run correlation studies to see how tightly that fit goes. Well, when you do carbon dioxide and temperature, what you find is that there isn't actually a direct correlation between CO2 and temperature. In fact, what you find is quite the opposite. What you find is that when you run a correlation, when you actually do the study, you find out that CO2 is the dependent variable and that temperature is the independent variable, meaning that temperature increases first and then CO2 changes. In fact, when you find the best correlation is when CO2 or temperature changes today and CO2 then changes 600 to 1400 years in the future. Okay, so to put that in real world terms, that's like saying water is boiling today and 1400 years in the future I turn the temperature on, or I turn the burner on. Or I'm drunk today and 1400 years in the future I drink a fifth of vodka. Okay, it doesn't make any sense. Any normal science would see this and say, this is a misspecified model. We have our independent and dependent variables mixed up. In the global warming science, what they do is they rewrite the laws of all science, and they somehow come up with a way that temperature changing today or CO2 changing today or in the future causes temperature today change today. None of it makes any sense in any kind of a logical scientific context. No way is it possible for CO2 to increase 1400 years in the future to cause any kind of a change today, simply because it hasn't happened yet, and it won't happen for another 1400 years. What's more disturbing is that scientists know this. You can do a search, correlation, atmospheric CO2, and temperature, and you'll see that it pops up out there. Now here's an example on how this is done. Okay, the best example I can think of how to explain this is, let's do a study having to do with weight loss. In order to determine whether or not the changes that you're causing lead to a loss in weight, you'd want to measure a few variables. The first thing you would want to know is exercise. You'd want to measure the exercise level of this person. The second thing you would want to do is you would want to measure the caloric intake of this person, okay? And then you'd want to try to keep everything else about as constant as possible. That's why they say these controlled environments. What you want to do is you want to put this person in an environment where you can change the exercise, you can change the caloric intake, and you can try to keep everything else the same so you can have as tight of a fit as you change exercise, you change caloric intake, you change weight. That's how you would run this thing. Now, one other variable you may think about would be the shoes. Okay, you would want to say, okay, let's measure the type of shoes that they wear. Now, in this scenario, let's say that I produce my report and I have all my data on exercise, caloric intake, and the type of shoes. Now, when I get to the end of my study, I find out that, you know what? I'm not getting the conclusion that I want. How can I make all this data fit my theory, right? Because what I'm trying to prove is that exercise doesn't cause weight loss, right? So what I would do is I would say, okay, well, I'm going to forget about exercise, and I would just drop it, and then I would keep the two variables, the caloric intake, and then the type of shoes that they wear. Now remember that that when you exercise, you're probably going to be wearing exercise shoes. So everyone that exercised heavily would be wearing exercise shoes. Everyone who didn't would probably be wearing dress shoes or shoes for work, right? So when I finish my conclusion, and I would be able to produce a report and show that caloric intake and wearing Nike shoes causes you to lose weight. You could do that with that kind of data. However, it's totally dishonest. The important thing is that every time someone exercised, they were wearing Nike shoes, but wearing Nike shoes did not cause them to lose weight. And that's what they're doing with global warming. They know that every time temperature increases, CO2 increases, so it's very easy for them to produce charts that show that they go along together. They don't want you to ask which one goes first. So in this situation, when temperature increases before CO2, they're counting on you not to understand that relationship, and not to ask too many questions, because when you start looking into the questions, their model doesn't hold any water. You see these kind of games played quite often in the field of economics. You'll often hear economists out there supporting a higher minimum wage. Well, this is the chart that you will find in every single economics textbook ever published outside Havana or Beijing. Okay? And it is simply a supply and demand graph, and you see above the equilibrium price, which is where the two lines meet in the center there, approximately about 2.5 up on price and about 35 on quantity. That little X, the center of that X, is what's called the equilibrium price. Now, if you go above that price, you get into an area that's called surplus. What surplus means is that you're supplying more than you're demanding. Now, a surplus in the labor market is what's called unemployment. Okay, so anytime you are to raise the minimum wage above the equilibrium price, you would get unemployment. Now, the only way economists that come out there and support the minimum wage and make these claims that a higher minimum wage won't cause unemployment is if you repeal the laws of supply and demand, and you can't do that. So you have to build a model that fits within the currently accepted laws of economics. So in this situation, what they do is they rely on the fact that they can go out there and find periods where they raise the minimum wage and unemployment didn't increase. Now, that could happen in multiple situations. One, if the equilibrium wage was already above the minimum wage, and you can simply determine that by looking at McDonald's. If it's paying $9 an hour and the minimum wage is $5 an hour, you can raise the minimum wage all the way up to $9 an hour, and you're not going to cost any jobs. But the fact is, when the economy turns and that equilibrium wage does fall, you create serious social problems. Like in the Great Depression, John Maynard Keynes identified this as sticky wages as the reason why we had such high unemployment in the Great Depression. So once again, even in the field of economics, where these people, every single textbook will disagree with them, you find people in economics still coming out and saying that they support minimum wage, even though in order for them to, their claims to be anywhere near true, that higher minimum wages don't cause unemployment, they have to repeal the law of supply and demand, which they simply can't do. And so when you get back to global warming, once again, that's a situation here where they're making a claim that So you get to global warming, what they're making a claim on is just like minimum wage. I mean, the minimum wage, you can have unemployment falling during a strong economy, and if you raise the minimum wage, unemployment still is going to fall, but it's not due to the minimum wage. It's like the minimum wage is like the shoes in the prior example. Well, in global warming, they're relying on a model where, like for instance with boiling water, water's boiling today and you turn the burner on 1400 years in the future. That model makes no sense. But once again, they're relying on you not understanding how to create a model. They're relying on you not understanding cause and effect. They're relying on you not understanding an independent and dependent variable. And actually, that's why we're creating this video series, so that we can use this global warming science, which is very bad science, but even bad examples are good examples if you can use them to learn. And that's what we're using their bad science for.